This section is about trees. So we learn about general trees and binary trees and various types of binary trees. So in this video, we'll learn about the terminology of trees and introduction to binary trees. So let us start with terminology. See, here I have taken a general tree and nodes are containing alphabets so that it's easy for you to understand. Let us define a tree. Tree is a collection of nodes or vertices and edges. Nodes and edges. These links are called as edges. If there are n nodes, then there will be n minus 1 edges. Because for each node, you can see that there is an edge coming over that node. There is an edge coming over that node. Every node, there is an edge coming from its parent. Except root. Root is not having a edge coming from any parent because that is the parent of all the nodes. So if there are n vertices, then there will be n minus 1 edges. This is a root node for the tree. And if I look at only this portion, all the nodes below B, then this is a subtree. D and all the descendants of D, all the nodes below D is a subtree. So if I define a tree, tree is a collection of nodes. Among those nodes, one node is taken as root node. Rest of the nodes are divided into disjoint subsets. They are in subset. This is one subset, this is another subset. There is only one node in this subset. And each subset is a tree again or subtree again. So I repeat the definition. Tree is a collection of nodes where one of the node is taken as root node and the rest of the nodes are divided into disjoint subsets and each subset is a tree or subtree. Now let us look at the terms. First, root. The very first node on the top is a root. Parent and child. A node is a parent to its very next descendants or those children which are connected with just one edge or those descendants which are connected with one edge. So for B, E and F are its children. For D, G, H, I are children of D. So D is a parent of G, H, I. N and O are children of L. L is a parent of N and O. So we have finished these. Now siblings. Siblings are children of same parent. G, H, I are children of D. So they are sibling to each other. G, H, I are siblings. J and K are siblings because their parent is same. N and O are siblings. Next, descendants. For any node, the set of nodes which are its children and their children and their children, so on. Or in other words, descendants are all those set of nodes which can be reached from a particular node or under that node. For example, for B, E, F, J, K, M, all these are descendants of B. For L, N and O are descendants. For D, G, H, I, L, N, O, all the nodes that are reachable from D, descendants of D. Next is ancestors. So for any node, all the nodes along the path from that node to root node. So for M, J, F, B, A are ancestors. For N, L, H, D, A are ancestors. The next is degree of a node. Degree of a node is number of children it is having, direct children, not all descendants, direct children. Degree of L is 2, it is having 2 children. Degree of D is 3. Degree of A is 3. Degree of F is 2. Degree of J is 1. And degree of N is 0. K is 0. M is 0. Number of children any node is having is the degree of a node. Then what is the degree of a tree? From the tree we cannot tell what is the degree. Degree is pre-decided. But if you observe, what is the maximum degree of any node? 3. See, this is having 3 degree, this is having 3 degree. So the degree of a tree can be minimum 3. Minimum, at least it is 3. Or it is more than 3 also. So I can explain you afterwards. Then coming to internal nodes and external nodes. Internal nodes, external nodes are also called as non-leaf nodes and leaf nodes, or terminal nodes or non-terminal nodes. What are those? Nodes with degree 0 are called as leaf nodes. Degree 0, degree 0, degree 0. So E, M, K, G, C, N, O, I, all these are leaf nodes or external nodes or terminal nodes. And those nodes whose degree is greater than 0 are internal nodes, non-leaf nodes, non-terminal nodes. Next, levels. See, level of a tree starts from 1 onwards, that is root is at level 1, then its children at level 2 and their children at level 3 and 4 and so on. So level starts from 1 onwards. So actually for level we count nodes. Here one node, horizontally if you see there is one node. Then at this level if you come, total 2 nodes are there. Either you count this 2 or this 2. We don't count all nodes, just the path. In the path we will count 2 nodes. Until here the path from root, that will take 3 nodes, 1, 2, 3. Either you come here or you come here, anywhere. At this level there are 3 nodes, 1, 2, 3 nodes. Then at this level there are 4 nodes, 1, 2, 3, 4 nodes. So we take the path by taking number of nodes. So that's how it is levels. The next is height of a tree. Height of a tree I will mark it here on this side. Root is at height 0 and its children at height 1, then height 2, then height 3 and 4. See, here we count edges. Till here there are no edges. Now if you come down to this next level, or let us say level only, or path, either you go here or here or here, then how many edges are there? One edge is there. So this is taking one edge to reach here. One edge. To reach here at this horizontally at this level, 2 edges are there. So 1, 2, 2 edges. Then till here 3 edges, then 4 edges. So level starts from 1 onwards and the height starts from 0 onwards. Height and level both are useful for analysis. Now coming to the last term, that is forest. A collection of trees is called as a forest. For example, here I will make a change. I have removed A, root I have removed. How many trees do you see? This is one, then this is just in single node tree and this is another. Total 3 trees are there. So this is a forest. Collection of trees is a forest. And if at all you want to make it as a tree by combining all the forests, then you can introduce a node like this. So here a forest is converted into a tree. So forest is collection of trees. So that's all with the terminology. Now I will introduce you to a binary tree. Now let us learn about binary tree. A tree of degree 2. Degree 2 means every node can have maximum 2 children, not more than 2 children. It can have less than 2 children, but not more than 2 children. So degree of a tree must be 2. If the degree is 2, then it is called as binary tree. By 2. So 2 children. So every node can have 2 children. A is having B and C. B is having D and E. Likewise, C is having F and G. As there are only 2 children, we will give the names to the children. This is left child and this is right child. So for B, this is left child and this is right child. So we give names as left child and right child. One more definition of a binary tree, that every node can have either 0 children or 1 child or at most 2 children. So children can be either 0, 1 or 2, not more than 2. Let us look at some examples of binary tree. I will draw some binary trees. I will not label them. This is labeling A, B, C, D. Just I will draw dummy nodes and look at the shape and find out whether it is a binary tree or not. Here I have some binary trees. First one. Is it a binary tree? This is not having any children. Yes, every node can have 0, 1 or 2 children. How many children is it having? 2 children. Okay, perfect. How many children? 0. Perfect. 2 children. Perfect. 0, 0. Everything is perfect. What about this? This node, 1 child. Yes, perfect. 0, 1 or 2. Remember this. This node, 1 child. Okay, perfect. This node, 0 children. Perfect. This is also a binary tree, and this type of tree is called as left skewed tree. So this is left skewed binary tree. And this one, this is another one. I'll just put a separation here. That is another one, third one. And that is also a binary tree, that is right skewed binary tree. What about this one? How many children? 3. No, this is not a binary tree. So when do you say it's not a binary tree? If any node is having more than 2 children, then you say it's not a binary tree. Less than 2 children is not a problem. So this is a binary tree, this is a binary tree. This is not a binary tree. This one is not a binary tree. Then what about fifth one? See, this tree, just rotate it with some angle. This is same as this one. Yes, we draw the tree like this also. Instead of drawing left right child, we draw down and right child. So this shape is also possible. So we draw a tree like this also. So binary trees are more commonly used. There are various forms of binary trees. We'll be learning them slowly. So in this video, we have finished the topic. I have discussed the terminology and introduction to binary trees.